Hi guys, so we are going to go ahead and do slides 2 through 5. So we're starting a new notebook, and so this is going to be a little different than the last quarter, where last quarter you had a different notebook for each content area or each topic. This time you're just going to have this quarter 3 notebook. So you're going to be the same notebook that you pull for the entire third quarter. So remember, you're not going to want to turn this in. You're going to want to hold on to it for the entire quarter. Just know that just because you're not turning it in does not mean your teacher cannot see it. Your teacher can go in at any time to her Google Drive and pull your notebook and see if you're doing your notes. So just because you're not turning it in, just because you're not clicking submit, doesn't mean your teacher can't see it. So keep that in mind. You need to be doing the notes along with the videos every day. But you just don't want to submit it because then it's not going to let you edit it anymore. If you do submit it on accident, you can, of course, always unsubmit, and then it will give it back to you and let you edit it. Okay, so here we go. So we are going to start off with the solar system and space for the first few weeks of this third quarter. So we're going to look at the order of the planets. We're going to look at the sun, the earth, and the moon, revolution and rotation of earth, all kinds of stuff. So today we're just going to look at the solar system and planets. Okay, so we're going to start off with a video.
Until August 2006, the International Astronomical Union, or IAU, recognized 9 planets in our solar system. But before that, new discoveries had led astronomers to believe that there might actually be 10 or even 12 planets out there.
This will absolutely rewrite the history of astronomy textbooks. There's now a 10th planet out there.
Mike Brown and his team at Caltech announced their discovery of UB313 in July of 2005. They have been involved in the planet debate ever since.
We're in committee limbo, international committee limbo, which is about the worst possible place you could imagine being.
The debate wasn't questioning whether or not the Caltech team had made a significant discovery. They had. The problem lay in the fact that no agreed-upon scientific definition for planet existed until August 2006. The ambiguity surrounding this issue made it hard for astronomers to classify their discoveries and complete their scientific investigations.
Did you know that in 1801, a new planet was discovered orbiting between Mars and Jupiter? They called it Ceres, and then they looked some more, they found another planet, and another, and another. The count of planets in the early 1800s was greater than it is today. 13 planets in the solar system. And they kept looking, and the numbers kept growing, and they were running out of names. And they realized, rather than counting new planets, they had discovered a new swath of real estate in the solar system called the asteroid belt.
Ceres was then moved into a different class. Instead of a planet, it became the biggest asteroid. The same dispute engulfed Pluto.
It's got enough ice so that if you were to take Pluto and transport it to where Earth is right now, the heat from the sun would evaporate the ice and it would grow a tail. And that's just no kind of behavior for a planet. We have words for things with tails. They're called comets.
So, what is a planet? After much deliberation, the IAU decided that a planet is a body that orbits a star, has enough mass to create its own gravity, has a round shape, and has cleared its neighborhood. According to this, Pluto is not a planet. It hasn't cleared the area around its orbit because it crosses paths with Neptune. So, it has been reclassified as a dwarf planet. And though it originally seemed that Ceres and UB313 were rocketing toward planethood, they now join Pluto in the dwarf planet category. But in fact, confusion continues because Neptune, which is still classified as a planet, has not cleared Pluto from its orbit. So, case closed? Not quite. Even though the IAU has provided a definition for planet, scientific understanding is always evolving, and as new discoveries are made, planet qualifications may continue to change.
Okay, so our solar system includes the sun, the sun, which is a star, 8 planets, at least 5 dwarf planets that they've found so far, comets, moons, asteroids, and meteors. The 4 rocky inner planets are those that are close to the sun. So that would be Mercury, Venus, Earth, and Mars. It's the first 4 planets are the inner planets. Then there's an asteroid belt, and then you have the outer planets. So you have Jupiter, Saturn, and the 2 gas giants, Uranus and Neptune, the 2 ice giants. So they are called the outer planets. They're the last 4 planets. The planets in order from the sun are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and we're going to go over the acronym to be able to remember that. Okay, so to be a planet, there are qualifications that everything has to meet. So a body that orbits, so it has to orbit a star. We all orbit, Earth orbits the sun, which is a star. And all the other planets in our solar system orbit the sun. Has enough mass to create its own gravity. So remember when we talked about gravity back in the first quarter, remember I told you gravity is the force, we think of it as the force that pulls us towards Earth, but remember Earth is not the only thing with gravity. Everything has gravity. Even you have gravity. But larger objects have a much stronger gravitational pull. And so the reason that we don't pull towards each other, even though we all have gravity, is because we're all overcome by the gravity of the Earth, which is way bigger than we are. And so likewise, we're all pulled towards the sun. All the planets are pulled towards the sun because even though all the planets have their own gravitational force, they all have gravity. They are all much smaller than the sun. And so the sun has the biggest gravitational pull in our solar system. And so all the planets are pulled into an orbit around it. But so for a body in space to become a planet, it has to have enough mass to have its own gravity. It has to have a round shape. And it has to have cleared its neighborhood, meaning no other planets can be in its orbit or intersecting its orbit. And remember on these videos, if I'm ever going too fast, you can always pause it to fill in your notes. All right, now we're going to label the planets in order, and I'm going to zoom in a little here so that we can see. So we're just dragging and dropping. So starting from the sun, we have Mercury. So the closest to the sun is Mercury. Then we have Venus. And so the planets are all kind of all over the place, but if you'll look at the rings, that shows you, if you'll look at the orbits, which is what these rings are modeling for you, then you can see first planet, second planet, third, fourth, fifth, sixth, seventh, eighth. Okay, so first planet Mercury, second planet Venus. Of course, that's us, Earth. Then we have Mars as the 4th planet from the sun. Then Jupiter. And so what we were talking about earlier, talking about ice giants and gas giants, Jupiter and Neptune are made primarily of gas. And so we call them the gas giants, and Saturn and Uranus are made primarily of ice. Oh, I'm getting off. Okay. All right. Earth, Mars, Jupiter, Saturn. Of course, with the rings, that one's easy. Uranus, and then Neptune. Okay, so make sure you label the planets in your notes. And now we're going to look at an acronym to help remember that. So here's just another illustration of the planets in line with each other. The sun, you've got Mercury, Venus, Earth, Mars. Then you've got the asteroid belt. So we're going to talk a little bit more about that later. But there is a large asteroid belt in between. So you've got the 4 inner planets and the 4 outer planets, and the asteroid belt comes between them. Okay, so the way that we remember the order of the planets, and hopefully this is something, this is not the first time you're hearing this. Hopefully you learned this or talked about it in 3rd or 4th grade, because this is more of a review skill for us. But the way that we remember it is with an acronym. So we try to remember at least the first letters of every planet. And if we can remember at least the first letters, then that will really help us remember the order. So we say my very educated or excited, whatever you want to put, mother just served us nachos. So if you can remember that little saying, then, and if you say it out loud, like if you're taking a test and you can remember the saying, then the idea is you write out the letters, the first letter of each word in that little saying, and then you have the order of the planets right there. So you have Mercury, Venus, Earth, Mars, and feel free to pause the video at any time. I know there's a lot of typing going on here. Okay. So this is just to show you that if you can remember this saying, my very educated mother just served us nachos, then that gives you the first letter of every planet in order. And so if you can remember the first letter, you're usually going to be able to remember the rest of the word or the rest of the name. All right, and some vocabulary for our last slide. So we're just dragging and dropping here. All right, the path that one object takes as it revolves around another object in space. So what we're referring to here would be these rings. So the path that Earth takes around the sun, and we call that an orbit. And so the picture for that would be probably, there's either of these could fit, but I'm thinking, oh no, it's going to be this one because she labeled orbit. So you can see the circle that shows the path that Earth takes is called the orbit. Bowl-shaped indentions are cavities on the surface of a planet that are caused by collision with another. So these are called craters. Earth actually has craters. We tend to think that only the moon has craters, but the Earth does have craters as well. But the moon definitely has a lot more. And they're easier to see because that's all there is on the surface of the moon. So we have the moon picture to go with our craters word. A natural satellite that orbits a planet would be a moon. Oh, wait. Okay, so yeah, moon and then, So what picture? Oh, it would be this picture. So this picture shows you the craters. This picture shows you the moon orbiting around the Earth or revolving around the Earth. And so we call our moon just the moon, but lots of other planets have moons and they have special names. But a moon, by definition, is any object that's orbiting around a planet, and we call them a natural satellite because we send satellites up into space to orbit around Earth, and the moon is like a natural one. All right, the star at the center of our solar system would obviously be the sun. It supplies heat and light to Earth, and its gravity keeps all of the planets in their orbit. A planet in our solar system that has life on it, so we are the only that we know of. We are the only planet in our solar system that supports life. And then the force that pulls objects toward the center of the Earth is gravity. All right, and that is it for your notes today. So remember, do not turn these in yet because you're not going to be able to edit them if you do that. Once you turn things in through Google Classroom, it doesn't let you edit them anymore. So do not submit this, just X out of it, and you'll pull it back out whenever we do notes again.